Yeah, I'm the third Kai Hudala from Bosch Software Innovations. I am talking about Eclipse hono. Eclipse hono is a project that aims at providing a uniform API for accessing and interacting with devices connected to a cloud backend, and doing that independently from the device communication protocol. So the idea is to abstract that away. And and another important issue is to do that in a scalable way so that you can basically connect all of your devices regardless of the protocol. The basic functionality that it provides is shown here. On the left-hand side you have things which are usually located in a local area network or maybe on a mobile network, and on the right-hand side you have the cloud where you want to deploy your applications and where you want to make use of the telemetry and the data generated by the devices. And what the picture is intended to show is that usually the telemetry direction is by orders of magnitude bigger than the command and control direction. That is simply due to the fact that the data is generated all the time continuously, but you usually only want to reconfigure or access your devices once in a while. They also have different qualities of service, if you will. So the telemetry data is usually in MQTT parlay that will be QoS 0, meaning if you lose out or a message gets dropped once in a while, that is usually not a problem. For example, if you have a temperature stream from a temperature sensor, it doesn't really matter whether you lose one temperature every 5 minutes or not, because the next value will basically come up for that. You can easily interpolate between them. However, for the command and control direction, that is different. You usually want to make sure that the command that you send to a device is actually executed and you get a proper response. So the telemetry is usually scaling out with a number of messages. You have to optimize for throughput there, and the telemetry is optimized for reliability, so you have to scale out with the number of devices there. So we incepted this in February 2016. Since last year, when I was here reporting, the numbers went up like that. That is not very impressive by means of total numbers, because we come from a very low basis. So, however, we are quite content, in particular with the number of contributors going up. We have more committers now on board, which makes life a little easier. We don't have the problems as Kai Zimmermann has, for example. So what we're trying to do is releasing an 05 version at the end of this year. And the 05 version is mainly targeted at providing the telemetry direction, getting that done in a way that it is actually usable in production, meaning it is reliable, it is scalable. We also have authentication of devices by arbitrary means. So devices, most of the easy or standard devices using standard protocols nowadays use username password authentication, but you can also do authentication using something like client certificates or more of the inherent mechanisms found in TLS. We provide a central component for that where you could use that you can use to manage credentials that are relevant for authenticating the devices. We also have a very basic device registry. However, that is not something that we would consider being useful for production, so this will be probably a topic for this afternoon, where we talk about integration options or collaboration between the projects. So I think device management is one of those areas. We are targeting for next year for providing command and control the other way around, the other direction. And we have split this up in this way so that it would be possible to actually make use of hono in a real use case, in a real world scenario first, in order to find out whether our approach for scaling out actually is sustainable, and before we actually start adding more and more features, in particular the command and control direction, which is very important to be sure that it actually works, or that the technology that you use underneath actually is fit for the task of delivering the messages reliably and in a scalable way. Challenges, it is quite hard to find collaborators having similar needs, because this technology is basically aimed at people who want to set up a cloud infrastructure. So we're not talking about people who want to connect 1,000 devices, but we're talking about people who might want to connect millions of devices. And these are usually people who provide a cloud infrastructure or want to have a service offering providing a cloud service for that. And there are not so many of these from my point of view, or from my experience yet. So if you have this idea, then you're very, very welcome to start collaborating with us. Consistent authentication and authorization is an issue because the applications that you want to deploy in the cloud usually come with their own idea of how to authenticate and authorize, and you want to find a way to integrate that properly with the device authentication and authorization so that you can make consistent authorization decisions as to which application or which user of an application has actually access to the data from the devices. Scalable messaging is an issue that is actually the subject of a talk that Dejan from Red Hat and I will do tomorrow. If you're interested, you can learn something about that there. And testing at cloud scale is also not that easy. Simulating millions of devices providing or producing data is, not really challenging, but it requires a lot of resources that you have to fire. Opportunities for collaboration. This is very similar to what I've shown last year, with one big exception. So obviously, we want to support more communication protocols. Out of the box, we support HTTP and MQTT. You might wonder why there is no logo of Mosquito in there in the MQTT box. That is simply because we are not using an MQTT broker, but we're also using or implementing the MQTT protocol to be able to connect devices and have them upload telemetry data. The Californian protocol adapter is something last year we had the Leshan logo in there, but nowadays I'm a little hesitant in positioning Leshan really in the protocol adapter. The protocol adapter should only be about translating or abstracting away the protocol, the communication protocol, which in this case is CoAP. And Leshan I would today see more as an application behind Hono. However, there is currently no work being done in that direction. And however, I am very keen on starting to work on doing a CoAP protocol adapter. And the Unite project is something that we want to integrate with so that we are able to properly upload PPMP formatted data into a backend system, and we're also looking forward to integrating Mono with Capua in order to provide a scalable device connectivity layer for Capua. I think that's it.
Okay. Questions?
Yeah, please.
I saw on the previous slide that you had integration with Kafka listed. Where does that fit into, or on the slide yet? Where would that fit into the integration?
Yeah, that is a good question. So all of this, as you see, is AMQP 1.0 based. Kafka obviously isn't, but there is a component that people are working on called the Kafka bridge, which on the one side takes in or speaks AMQP 1.0, and on the other side is able to forward that data into Kafka. So what many people with a telemetry ingestion pipeline want to do is buffer telemetry data in a Kafka cluster, and that is what would be possible that way.
Thank you.
Any other questions?
Yeah, probably the MQTT bridge for Kafka. Actually, we have the MQTT bridge in production. So, how far is that? How major is that? The MQTT bridge?
It's not an MQTT bridge; it's an AMQP.
Yeah, right. I say we have an MQTT bridge in production. So we're considering using hono then. That would be the switch then for our Kafka infrastructure.
Mm-hmm.
How major is that?
I have no idea. I'm sorry. I wish Paulo were here. I think he's working on that. Yeah, but I don't know. I'm sorry.
Is Paulo coming?
No, Paulo's not coming. No.
Okay. Anything else? Okay. Thanks, Scott.